in this stream today, we will be talking about Berachain and how you can build on Berachain using QuickNode. But first, we will have to understand about Berachain and how it became the sixth most total value locked chain. So today with us, we have Barry, who works as a DevRel engineer at Berachain, and he will take us through what Berachain is, how it works, what's the novel proof of liquidity consensus mechanism, and everything around Berachain, how it became the top DeFi player in the space, and how it's attracting new projects on the chain. So, Barry, I will pass it on to you so that you can give a little bit introduction about yourself and then dive more into what's Berachain and a few more concepts about Berachain.
Thanks, Sahil. Nice to meet everyone on the stream. Thanks for that quick intro, quick hitters on Berachain. There's a lot more to dive into, which I'm excited to go over in the next 30 minutes or so. But to start off, for those who aren't familiar with me, my name is Barry the Cucumber. I'm a developer relations engineer at Berchain, specifically focusing on DeFi. I've been in the crypto trenches for a long time. Started building in the obscure field of Web3 legal engineering back in 2017. Went full-time in crypto 2020 during DeFi Summer, where I co-founded the project Pickle Finance. It was a yield aggregator. I moved on to do DeFi DevRel at Reserve Protocol before landing at Berchain about a year ago, doing DevRel as well, because I wanted to see a bigger ecosystem impact of my work. A high-level overview of Berchain for those who aren't aware. We're looking at the docs here. Berchain is a high-performance EVM identical layer 1 blockchain, utilizing proof of liquidity, which is built on top of consensus framework called Beaconkit. We can unpack a couple of these different concepts because in this one sentence, there's a lot that's that we can get excited about for Berchain. So proof of liquidity is something many people have heard of surrounding Berchain, but a lot of people don't fully understand what that is. At its core, proof of liquidity aims to tackle the issue that chains are overpaying for security and under investing in economic activity and liquidity. So take, for example, these giant Cosmos chains who have about $2 billion, $3 billion in terms of their native token staked by validators. That's $2-3 billion in security, but ultimately, that chain, those Cosmos chains attract 5, 6, 7, up to 10 mil in TVL. So there's a big disparity in the economic security of the chain and what that each dollar of that economic security goes towards securing very little actual economic value. Berchain flips this idea on its head that chain incentives and rewards should go primarily to validators, but instead we want to, validators do an important job too. They secure the chain, help blockchain reach consensus and progress the state. But what's also very important for the liveliness of the chain is liquidity, which is why we term it proof of liquidity. A lot of the vast majority of native chain rewards go towards people providing TVL. And so this is a very DeFi focused mechanism, which the founders have recognized is sort of the lifeblood of blockchain. Blockchain is primarily an economic invention. In its current state, DeFi is the most useful use case. And so we want to strongly couple the success of a chain with how many users are on it, how much money and economic activity and innovation is flowing through it. And that's actually worked quite well since launch. It's been live for nearly a month now. And as Sahil mentioned, we're number 6 in terms of chain TVL. And that's, I find that pretty impressive and promising for a chain that's only a month young.
Where does the name come from? And why Berachain? Why a chain would be called Bera? Because people usually associate bear with bad times and downfall and stuff like that. So that's very interesting choice for a name of a blockchain. So if you have anything to share on that, that'll be interesting.
Yeah, it's funny you mentioned that because it actually gives us somewhat of a superpower. because if you're bearish on Berchain, that's bullish. If you're bullish on Berchain, that's also great. But word jokes aside, Berchain had pretty non-traditional beginnings as a blockchain, and actually this docs page explains a bit of it. Berchain started off in 2021 as initially an NFT project, bear-themed NFTs. The first collection, Bong Bears, which are they're pictures of bears smoking weed. They attracted a lot of DeFi native, pretty high signal crowd that had there was a lot of builder energy, and it was an NFT collection that rebased. So there were subsequent collections after the Bong Bears. There were the Bond Bears, then the Boo Bears, etc., where holders of each previous collection got airdropped the new collection as well. And so that sort of an organic community grew that way. These, if you can see on my screen, is the Bong Bear NFTs. They're worth quite a silly amount of money, at least 20 ETH is what I'm seeing as the last sales. And then the listed ones, just a lot of these aren't listed at all because these are held by sort of really OGs who don't necessarily need money. They're in it for the vibes, and they sort of they're aligned long term. And holding one of these from day one would have given you a lot of value in terms of the community that you've been granted access to. Which has grown to such a large degree these days. It's a lot more decentralized than it used to be. But also, there was an airdrop component rewarding sort of these NFT early community members. But that's so getting back to the origin story, all that sort of builder energy culminated in the creation of a chain, and things went from there. We found interesting economic innovations in terms of proof of liquidity, but also technical innovations in terms of Beaconkit, which sort of pushes the modular landscape forward, which we can talk about later. But yeah, end of the day, we have a chain with bears on it, and people seem to be incredibly bullish of that.
And the thing is that I would say it's very clever of the founders that they actually acknowledged the finance part of everything in crypto, because to be honest, everything and anything we do in blockchain is somewhere related to finances. And the thing is that people are not ready to accept that, and building an entire chain around just that aspect is very clever. So are the founders from like DeFi or traditional finance background, or are they from the validator background? Because even validators are kept in mind in this chain, and like the liquidity in general is kept in mind in this chain. So if you can talk more about that, like the background of founders. You have already talked about like what went into the thinking, or think what was the thinking process behind the chain. So just wanted to understand the thinking process of the founders or their backgrounds.
As you could probably assume, and you probably alluded to it, the founders are extremely DeFi native. They've been in crypto for a very, very long time, but they're also veteran tech founders. They've worked in a variety of different industries and verticals, actually. Some in biotech, some in real estate, traditional VC, of course. So all that came together, and that was I guess looking back, a good recipe for developing novel chain mechanisms.
Yeah, thanks for sharing that. And Barry, like I would like you to talk more, or I think our audience will also be really interested in learning more about proof of liquidity and the multi-token structure that Berachain has.
Yeah, the proof of liquidity is somewhat enabled or powered by the fact that we've split the native tokens into two. Typically, for most chains, think Ethereum, ETH, the native token is responsible for all of the functions of gas, economic security, of economic incentives.
Yes.
People stake them. It's given to validators as emissions, as rewards, and also users pay gas with it. We've recognized that by sort of segmenting and siloing certain functions into two different tokens, you get the benefits of specialization. And in Berachain, the two tokens are Bera, B-E-R-A, and BGT, Bera Governance Token. The Bera token is responsible for gas and economic security, whereas BGT is responsible for governance of the chain, and it's issued as the economic incentives for providing liquidity as part of the whole proof of liquidity paradigm. So in practice, how this works is a user, a farmer like me, for example, could come in and provide liquidity, say Bera WBTC on the native DEX, which we call BEX. They stake the receipt token from providing liquidity into what we call a reward vault. These reward vaults have BGT sitting in them as incentives. BGT, where the incentives go, is dictated by validators, and there's sort of an economic game they play, depending on, they could direct their emissions towards certain vaults and get a kickback in the form of incentives that protocols give them. And so in this manner, we sort of amalgamate all of the chain's rewards and incentivization programs under one umbrella into BGT and POL. But that's a bit of a tangent. And so, user stakes their LP and they get BGT in return. With this BGT, they can delegate it back to validators. A greater BGT delegation on validators gives them more influence in where emissions go. And from their emissions, as I mentioned, they receive incentives from protocols, which are kicked back to the users. So in short, users holding BGT is earning passive income in the form of continued POL rewards. So it's auto compounding in that manner. But say you no longer want to participate in this in the chain's economic incentives. You want liquidity or you want gas. The only way to obtain Bera tokens, the gas token, is to burn that BGT in a one-way transaction for Bera. So it's a one-to-one trade. One BGT is burned for one Bera. But obviously, that transaction foregoes a lot of the economic incentives in exchange for utility and liquidity. And so there's somewhat of a premium that we're noticing on the market right now for BGT. BGT is non-transferable. So we notice a premium in the sense that there's liquid staking providers, sort of like Lidos. There's an equivalent on Berchain called Infrared. Stride also operates another one. And this liquid stake form of BGT fetches a premium because it's economically productive. And that's sort of the economic game we expected to see playing out. Hope that answers your question. But basically, two tokens, one responsible for economic incentives, the other for security and gas. And that sort of enables PLO to happen.
You were also talking about Beaconkit, right? Like how people can, somewhat related to Cosmos ecosystem, where how people can make their own chain using Beaconkit, which is again developed by the Berachain team. And I know you were talking about this yesterday, that this is a public goods project from the Berachain team, and anyone can use it to build their own chains. So if you want to talk about that, like how does that work and how people can actually build their own chains on top of Beaconkit or using Beaconkit?
Totally. Yeah. So this dives into sort of the more technical architecture and plumbing of Berchain itself. A lot of people understand it as an EVM chain with some Cosmos elements. Great. Like, what does that actually entail? So actually, it's probably helpful to pull up this presentation that was developed for DevCon. We won't run through the whole thing, but we'll go through the highlights. Berchain in its first iteration, many people may have heard of Polaris, and that was an implementation that wrapped the EVM within Cosmos consensus, within the Cosmos SDK. It was more of a monolithic architecture, and that ultimately didn't play well. We saw that in our first testnet, artio, because the transactions were too high for Comet BFT to handle on its own in the context of a bundled EVM. So that didn't play out so well. And the next iteration was adopting more of a modular framework and philosophy, which we call Beaconkit. It's a modular framework for EVM consensus clients. And the architecture for this is extremely simple. So for those not familiar with ETH2, that's after Shanghai with proof of stake. every validator runs two clients. They run the execution client, which runs the EVM. That's what we're familiar with interacting with. And there is on the other side, the consensus client, which is responsible for validators reaching consensus on the blocks that are produced and how the chain progresses. The EVM has most of the developer mindshare in the space. Solidity is a pretty widespread language at this point. The tooling has become pretty mature for it. I think Foundry, QuickNode, Tenderly, all that good stuff. Developers familiar with that. So we want to maintain those properties. But we thought that there was ways that the consensus client could be improved and iterated on. So what we worked on primarily was the consensus side. Instead of adopting Ethereum's consensus, we plugged in Comet BFT, which underlies the Cosmos tech. But we found that to give several benefits. The single slot finality, whereas Ethereum takes about 12 minutes for transactions to fully resolve. With Berchain and Beaconkit, you expect them to resolve instantly. The transaction times we've also noticed to be super fast.
In the last slide, you had the architecture of node for a Beaconkit node or a Berachain node. So in this sense, your Beacon D client basically just replaces your Teku or Lighthouse clients in terms of Ethereum.
Yeah, exactly. Okay. That's right.
Got it.
And on the great clarification. And on the execution side, validators can run any supported EVM execution client. That could be Geth, Wrap, Aragon, Nethermind, etc.
Yeah.
And what Beaconkit actually looks like is it's sort of a middleware layer. Comet BFT is the underlying consensus mechanism, but it has to be able to take Ethereum package blocks and run it through its consensus lifecycle. So there's a ABCI middleware layer that packaged within Beaconkit, allowing Comet BFT to play nicely with Ethereum blocks. And this is all so a developer, an L2 or L1 developer down the line could take Beaconkit and plug it into their own execution stack. It doesn't have to necessarily be the EVM clients. It's whatever is compatible with Engine API. But even further to that, you can it's further modularized by this ABCI middleware component. You could plug in another consensus engine, for example. It could be Avalanche's Snowball, I think. Frostbite, I forget what the name is. But it would also equally be compatible. And so Beaconkit is pretty flexible in that sense, and we're excited for developers to leverage it. But as of the present day, this is what powers Berchain, and we found it to be quite performant, and validators have a pretty easy experience because it follows the typical ETH2 paradigm.
And just for clarification for our audience, this is not exactly similar to what OP Stack or Arbitrum Orbits is, right? And I know people are creating layer 2s on Bera as well, but Beaconkit is completely different thing where they can create their, let's say, maybe own layer 1, or
that's correct, yeah.
And create layer 2s, but it's not just limited to that, right?
Exactly, yeah. So layer 2s, that's a very fine distinction, but an important one. There are going to be layer 2s on Berchain, which inherit from Berchain's economic security. But those behave similarly to the relationship between Arbitrum and Ethereum, Optimism and Ethereum. Those chains could be built with OP Stack, or they could be built using Beaconkit. That's there in their domain to design and do whatever fits their engineering needs. But Beaconkit specifically is just if we look at it in isolation, it's a modular building block for chain developers. TLDR, it works well. Comet BFT in the context of EVM execution, single slot finality, fast block times.
Barry, I had this another question that like your team and our team, basically the Berachain team and QuickNode team, have been working with each other for a long time now, a lot of months, not just during the time of mainnet, but way before that. So just wanted to understand your experience around that. Just wanted to understand your experience around this partnership and how everything has been going. What would you like to see more? What would you like to see in the future? How things have been in the past, etc.
This requires a little bit of explanation and context. So QuickNode is a very close partner of ours during a very important pre-mainnet phase, where it was a period of about 2 to 3 weeks where critical partners deploy their infrastructure before users would come onto the public mainnet. Think providers like Stargate, Layer Zero, node providers obviously like QuickNode, Gelato for automation, Foundry for Ethereum tooling, things like that. So we had to enable RPC access to the chain, but another very important criteria at the time was to preserve the secrecy of the chain's existence. We couldn't let people know that the chain existed, and God forbid an RPC leaked and people could use the chain before it was public. That would be a big disaster. And so working with QuickNode's security features, and this is all of it available on their UI, let us do this pretty seamlessly. Obviously, there's a bit of friction with trying to prioritize security and secrecy over moving fast and enabling our partners to deploy. Depending on partners' needs, we were able to sort of lock down RPCs with either IP whitelists or JSON web tokens, and partners were still empowered to deploy. And we went through that period successfully, thanks a lot to how easy QuickNode was to use.
Barry, before we move on to the section where I show people how they can build something on Berachain using QuickNode, there is a question from Carl. Actually, there are two questions from Carl, but one is very topical. Can you explain the new Bera testnet and why was the change? Because I remember there was a testnet called artio previously, and then there was a change and the new bartio testnet came in. So what was the change about and why there was a transition from the old one to new one?
Yeah, that's a good question. So let's go over really briefly the lore and the timelines of the different testnets. The first testnet, artio, was a Polaris implementation. That's the one that didn't quite work because it was the monolithic architecture. Transaction volume was too high to handle. Next came bartio. Bartio was the first time we used Beaconkit, the more modular architecture. It worked well, but it was lacking in a lot of things compared to the current mainnet version, in that a lot of the POL contracts weren't calcified yet. There were a lot of changes between that and mainnet. And so someone developing on bartio today wouldn't be interacting with the same POL contracts. And so that sort of necessitated a new testnet because it's tied it's coupled so tightly with the chain's incentive mechanisms on the consensus layer, how it issues rewards, stuff like that. A lot of the core code has changed as well. For example, staking logic, withdrawals. A lot of the core engineering team has expanded a lot in the past half year to sort of add more robustness to the chain. And so a lot of those core upgrades were hard to backfill on bartio. And so the decision was made that it's just better overall to have a new testnet completely reflective of current mainnet state, and that will try to maintain perpetuity now that the chain's live, and it's going to be more upgradable in that sense. For design with that in mind. And in terms of timeline, I know a lot of teams. Some teams have been left in limbo because they rely on the testnet, and with the deprecation of bartio, and before Papolia comes out, the next testnet, there's currently no testnet, and I understand that's a bit of a struggle. But it should be out soon. We expect by next week, and we're going to have more docs and communications around that soon.
Thanks for answering that, Barry. And Barry, before we end the stream, I would just like to show a very small demo of how people can get started with the Berachain on QuickNode. So if you don't mind, I will take the screen share away from you and share my screen.
Please take it over.
So this is how your dashboard will look like, and if you want to create a new endpoint, which is a RPC endpoint, you basically go on create endpoint and then choose Berachain. So once you click on next, it should take you to the add-ons page where you can choose between the add-ons. So basically, add-ons are your marketplace add-ons, which are provided a lot of the times by third parties and sometimes by QuickNode team as well. And they are high-level APIs, which you can use on top of your normal RPC endpoint. For example, this translate API from Noves, this Forex API, for example, translate API lets you translate your transaction, which is in just hashes, but translate API will give you a transactions explanation in a human readable format, in a more human readable format. So those were examples of add-ons, but once you create an endpoint, and if you remember, Barry was talking about IP whitelisting and JWTs, which are security measures or ways to secure your endpoint. You would be able to do those or enable those after going to the security tab of your endpoint. And you can see you can limit by IP address, you can limit by methods. For example, you can just limit your RPC endpoint to serve particular methods. You can do token based authentication where you can create and delete tokens, which are your API tokens. You can add a JWT, which is JSON Web Token, which is the most secure form of securing your endpoint. Then there are different kinds of whitelisting where you can whitelist domains, you can whitelist domain referrers, source IPs, etc. But these are for RPCs. Now, I wanted to talk about a new format or a new form of getting blockchain data, which is streams. So the thing is with the RPCs, it's a pool-based mechanism where you request some data from the server, in this case, a blockchain node, and then that data or function gets executed on the node side or the server side, and then you get the data. And for every new piece of data, you will have to do that mechanism every time. But with streams, what happens is you get the data as soon as that particular action occurs or happens on chain. So it's a push based mechanism. So in this case, you won't have to go to the blockchain node again and again asking for the data, but you can just get the data whenever that data is available on chain. So in this case, what I have done is I have created this Berachain block metrics dashboard, very simple one, where I am getting total number of transactions, total contracts created, active addresses, total beta spends, etc., from the chain, and displaying it on this. So I said that streams is a push-based mechanism, and you get the data whenever it's ready on the chain. But it's not just that; it's a lot more than that. So the basically what you can do with QuickNode streams is you can eliminate your entire ETL pipeline with just one tool, which is QuickNode streams. Now, how that would work is something like this. If you go on to create a stream, and it will be Berachain in this case, mainnet. So what you can do is you can index an entire chain as well. In that case, you will have to select a starting block. If you want to index, it'll be a starting block as 0 or 1, which will be the genesis block, or you can just start your stream from the latest block. And you can index the chain between particular blocks, which is a block range. So you can mention a starting block, you can mention a ending block. So let's say that you want to start from 0th block and end on 100th block. So that's possible. You can index just those 100 blocks. Or if you want to start on 0 block and run stream continuously until paused, this means that you will be indexing all the latest blocks which keeps on coming in. And you can also do that starting from the latest block right now. Now, there are multiple reorg handling options as well, where you can set a latest block delay. For example, if you set this to be 10, your latest block will be sent after the 10 blocks have been passed after the current latest block, so that it eliminates the possibility of reorg being happening. So for example, for a chain, if you know or if you are certain that a reorg might happen between like 20 blocks or 30 blocks, so you can set this block delay to be 20 or 30. And then there's this another option where you can restream on reorg. For example, if a reorg happens, it will restream that particular block which has been reorged to your destination. We will talk about destination later, but let's first talk about how you can solve your ETL headaches in blockchain. So this part is where you get the data. So this is extracting the data. Now comes the transforming data part, where with RPCs, what you do is you get the raw data from blockchain, you do transformations and updations on your end, and then you show the data or load the data into your applications. Over here is the block data set. You can choose between multiple data sets, but let's just take an example of block data set. You can also batch messages if you are indexing like blocks in the past, or if you are backfilling the chain. For faster backfilling process, you can batch your messages, which means that you can get multiple blocks sent to your destination in just one message. So in this case, 100 blocks will be sent to you in just one message. So it will basically make your backfilling process a little bit faster. Now we had selected 0 blocks, so that's why it was 0 over here. And if we add a particular block number, this will be the example of data set. This is how the raw payload will look like. But the thing is, we do not want the raw payload. We want specific data from the blockchain. And in this case, what you can do is you can just customize your payload so that you do not have to do the transformation on client side. In this case, you can do that entire thing on server side itself. So for building this app, we will get all of this filtered data directly from streams. We won't have to do anything on our end. We won't have to do data filtration or handling data on our end. So once you click on create a custom filter, you will be prompted with some filter examples. For example, filter ERC token transfers, filter stablecoin transfers, filter or get decoded Uniswap swaps, etc. But in this case, we will have to create a custom filter example. So what we are doing over here is getting the payload and then getting these data or data values out of it. For example, we are getting total transactions, we are getting active unique addresses, unique tokens being transferred, we are averaging the gas prices in Wei and Gui, looking at transactions. Then we are also getting the largest transaction by value within that particular block, and then we are just returning that. So this is how you can write your own filter. It's very similar to your JavaScript code. So you can write your own filters and get the filter code fed directly into your destinations rather than, transferring on your end or client side. So in this way, you save a lot of processing and resources. So let's run the test for this particular block. And you can see that we have gotten the response like this, where we have the active address count, average gas price in Wei and Gui, the current block number, contracts created, largest transaction, its hash, and the value of the largest transaction, total beta being transferred in that particular block, transaction count, and unique tokens interacted. The next part would be loading. So what we have done is we have set up the extraction part, we have set up the transformation part, which is transforming the data, and the next part is loading, where we transform, extract, and load the data to a particular destination. Click on next. All right. So this is the loading part where I can select from these destinations. It can be a webhook where your app can fetch from. It can be a AWS S3 bucket, a Postgres instance, or a Snowflake instance. But you can also create or add a serverless function, a QuickNode serverless function as your destination. So let's say that you get data from streams and call another RPC method based on that data. You will be able to do that using a QuickNode blockchain serverless function. So it gives you a lot more capability to do something with your data, not just get the data, but you can also do operations or further operations with your data. In this case, we will be just setting up a Postgres instance because we will have a next app or Next.js app which gets data from that Postgres instance. So this is how you will set up your Postgres instance, where you will fill in all of these details and then create the streams. In our case, I have already created a stream and index few blocks. For example, if you can see over here, I have already indexed block 186968 from 185998. So I have already indexed these blocks. And if I start this stream again, I should get newer blocks in this database table to be specific. And this is how our app looks like. This is set up to update every 3 seconds, where it polls the database table which is this database table, every 3 seconds to get the latest block number. So you might see that 190030310 was the latest block number, but now that was 499. That's because the block production rate in Berachain is much faster than 3 seconds, and our app is just getting the latest block at that time in that table. So what we did is we just set up a Postgres handling script over here where it's connecting our Next.js app with the Postgres database instance using the Postgres URL, which we have saved in the environment variable like this. And it's interacting and getting the latest block number. And we can also search for a particular block number in the past. And in the index.js, we are just creating state variables for all the different states where we have state variables for block data, if it's searching or not, latest block number, etc. Then we are creating structures for our web page and just adding a bunch of styling in the same page. But in production, obviously, this won't be the case. This is just a demo app. So it's that simple. You can create your ETL pipeline right within the QuickNode's stream part and have your app just do minimal things. Like this app is very minimal. It's just connecting to a Postgres instance and creating the structure for this app components over here and getting everything from streams. So if streams was not the case in our app, we would have to set up everything from our RPCs, getting data from RPCs, transforming data which we get from RPCs, and then pushing that data into a Postgres instance, etc., etc. That would have taken a lot of time and efforts and made our app, which is like very simple right now, a lot more complex and added a lot of overheads on the app. So this is how QuickNote Streams can be used to make your data extracting and filtering process very easier, and also loading your data into your preferred form of destination very easier. We can also search for a particular block number. Okay, let me undo that. For example, like this, if we search for a particular block number, yeah, you can also search for a particular block number, but it's set up to update every 3 seconds with the latest block number. So that's why it will keep on doing that. Let me stop this. Yes. So this is how streams can be used and take away a lot of coding process and part away from you and give you those valuable hours back where you can focus on building other cool features rather than, just giving a lot of time in data processing and management part. Thank you so much to everyone who has been here from the beginning. And thank you so much, everyone, for supporting this stream. We will see you in the next one.